Hello and welcome back. This is the last video in a 5-part series introducing RapidMiner Studio. In this video, we're going to learn on how to validate a model that we built in the past videos. If you haven't watched the past 4 videos, please do so now because they are the foundation for this last video. Before we begin, let's take a look on the right side here. Let's see where that yellow arrow is now. It's currently at the evaluation stage of this business process cycle. The evaluation stage is very critical, especially if you're getting ready to deploy a model to support your business decisions. You want to know how accurate is the model and can you actually reasonably and with confidence use it to make your decisions. So let's get started. Let's load up RapidMiner Studio. By now you should be pretty familiar with it, so let me switch over to it. You should see the familiar splash page. But today, instead of doing a new process, we're going to actually open one that we created in one of those past videos. We're going to come over here, pull down this arrow, and select 02, Build Decision Tree. So let's click on it and load it up. We will talk about validating the model at a very high level. We will talk about things such as cross-validation, training, and testing data sets, as well as a confusion matrix. Don't let these things scare you. We will keep it at a very high level. So let's take a look at this process. Do you remember it? Well, if you don't, let's just refresh our memories here. First, we loaded in some customer data. And in that customer data, we had rows that had customers that have either churned or have been loyal, or there were missing values, there were question marks. Well, we built a decision tree model on only those rows that had loyal or churn. We filtered out all the missing rows that did not have churn or label in them. So what essentially we did was we created something called a training data set of only the examples that had loyal and churn in them. And we built a decision tree from that. Later on in the last video, when we showed you how to score, we actually took those missing values, those missing rows that didn't have churn or loyal in it, and used that as a test set to try to predict and put those unknown customers into the loyal or churn bucket. So that's what training and testing is. Training is a data set that you use to build a model from, and testing is the data set that you use to test the model. So we still didn't know from the last video really how accurate our model was. We got something called confidence levels and a prediction. But what about trying to understand how good the model really did predict from something in the training data set? So let's show you a way on how we could do that, and then later on show you the better way to do it. So let's first do this. Let's go ahead and get something called an apply model. If you remember, the apply model is an operator that applies the model you created. So let's go ahead and connect the decision tree MOD port, stands for model, to the apply model operator here. Okay, excellent. Now let's try to use some of the unlabeled data, or in this case the data from the filter here, to try to make a decision and compare what the predictions would be. So let's drag this example port over to here to the unlabeled. And do you remember you'll get that familiar little icon to make a copy of the data? Let's go ahead and do that. Let's click on that. Excellent. So, and now let's connect the labeled output to the results. So what did we just do here? Let's take a moment and think about it. We load in the data. We filter out the missing rows that don't have label or churn, and thereby we created a training data set. Then we made a copy of it. We fed the training data into the decision tree and built a model, but we kept a copy of it and drove it down to this branch here, and where we took that same training data set and applied the model to it, and now we're going to compare them both. So come over here and hit run. Okay, what do we have here? Well, do you remember in the last video, video number 4, when we made predictions, we created a prediction column, a confidence column, and a churn column. So now let's take a look at the data. This column was what we were originally filtered out, so let's compare them. Loyal, loyal, good, the prediction was correct. Churn, loyal, the prediction wasn't correct here. Loyal, loyal, prediction was correct. Loyal, loyal, prediction was correct. So you can see here that you can add up all the mispredicted ones and compare them to the churn column, and from there you can get a percentage on how correct your model is. Well, you could do this by hand, or you can let the computer do that and get a deeper, more valuable insight. So how do we do that? How do we actually let the computer count all these up and give us a percentage on how accurate the model is instead of doing it by hand? In RapidMiner, we can do that by using one of our validation operators. So let's switch back to the design perspective here. And let's go ahead and do some modifications to this process. Okay? First, let's go ahead and do this by getting rid of the multiply, getting rid of the decision tree operator, and getting rid of the apply model operator. And let's come over to our operator and search for cross-validation. Now in RapidMiner, the word cross is actually represented by a little x. So put an x, put a dash, and look for validation. And there you have it, cross-validation. So let's drag that over here. And let's connect the example from the filter to this little nub called TRA, which stands for training. Before we dive into what we need to do with this validation operator, let's talk a little bit about what cross-validation does. So if I look on my parameter window over here, I have something called number of validations. The default is 10. So what does that mean? Well, when I have the default of 10, or I can make it 5 or make it 20, doesn't matter, it will take my data set and break it into 10 smaller subsets of data. And then it will go ahead and build a model on 9 of those subsets and keep one of those subsets for testing. And then it will iterate over that. Sounds confusing, doesn't it? Well, let's take a look at an image here, and we can maybe clear up some of this confusion. In this particular case, we have a data set that has five cross-validations. So you can see here 1, 2, 3, 4, 5. And so the way the cross-validation does is it breaks it into 5 subsets right here, the data, trains on 4, and then builds a model on this one here and measures the performance. Then it iterates. It selects another 4, this one different ones, and selects another separate test data set, and then builds a model, measures the performance, and finally begins to average that. So it'll do that over the entire 5 or 10 validations and give you an average performance of the model. So let's switch back. So essentially what we're doing here is we will be building 10 decision tree models and averaging their performance together to get an understanding of how good this model is, how stable is this model on the data. Okay, before we do that, we need to dive in underneath the hood here of this validation operator. You see these two little windows? Whenever you see that on any RapidMiner operator, it means that there's something going on underneath the hood. It's a sub-process typically. So double click on that. Okay, now we actually have 2 new windows. Do you remember that term I said, training data and testing data? Well, in the sub-process of this validation operator, I have a section for training and I have a section for testing. Okay, so what do you think would go into this training window? If you said decision tree, you're right. So let's put the decision tree operator in here. I'm going to pass my data, my training data, to this decision tree and build a model from it. So I'll connect the MOD to the MOD port. Now, I'll need 2 operators here. One, if you guessed apply model operator, you're correct. But another operator that we'll need is something called performance measurement. So remember this little image? Let me refresh your memory. Remember here, we're training a model on these 4 and then testing it on this one and measuring the performance. So here is our decision tree algorithm. Here is the apply model, and we'll need a performance operator here to measure the performance. Pretty straightforward. So let's switch back to RapidMiner. Let's find the performance operator. There's a whole bunch of them, but we're going to use a very simple one just called performance. Scroll down here, highlight it, drag it over here. So before we make any of these connections, let's talk a little bit about them. Here in the training window, I create the model. I train a model, and I pass that model through here. Now I'm going to take that same model and attach it to the apply model operator. But remember that unlabeled data? Where do we get that from? Well, we get that from this little nub here called TES, and that stands for testing data set. Do you remember we're saving one subset of data for testing? This is where it comes in. So let's connect that. We get the label performance and we output it here to this performance operator. And finally, we output the PRE, stands for performance, to an AVE port. Do you remember we build 10 decision models and we averaged them all together? Well, that's what the AVE port stands for. Great. Now we're ready to run the model. Let's go up one level outside of the subprocess. Come back here to the validation operator. Select the AV port to output. But before we do that, why don't we save this process? So let's expand our local repository in the local left, pardon me. Highlight process, right click, store process here, and let's call it 04 validate model. Now, when I run this, when I click on the play button, I will get a result. And we will talk about that result shortly. So let's go ahead and run it. Okay, these are the results. Well, what can we make of this? I have something called an accuracy. I have these pred loyal, pred churns, true loyals, true churns. I got some percentages here. What does all this mean? And how do I use this to actually understand how good my model is? It's quite simple. Let's start over here with the accuracy. So the overall accuracy of all 10 models that we created, decision tree, is 83 point, let's say 84% accurate. But what's this plus minus over here? This plus minus is one standard deviation. So as we built 10 different models, some were maybe better than 84%, some were a little bit less than 84%, but the average accuracy was about 84%. So the lower this number, this is a critical, important item to note when you're evaluating your model, that the lower this number, the lower the one standard deviation is, the more stable your model is. If this number was, say, 10% and we had 84%, you could have a swing from 94% to 74% accuracy. So it may be good in your particular use case, but a lot of times a smaller number here means a better model and more stable model. So let's take a look at this box down here. Like I said, we'll keep this very high level. You can definitely read more about confusion matrices on other sources in RapidMiner or on the net. But let's just take a look at this. Pred loyal, it stands for predicted loyal. Pred churn stands for predicted churn. So let's see what these numbers are here. Well, as we were building the models, we had a total of 509 plus 69 loyal candidates. Okay? And when we ran the algorithms through, they predicted loyal 509 times that were actual true loyals. And 69 times it predicted churn when in fact it should have been a true loyal. Oops. Over here, let's take a look at the churn column. 76 times out of our data set we predicted loyal when in fact it was truly a churn. But 246 times it predicted churn and it was truly churn, so it was correct. A really handy way to look at is to look at this diagonal here. You can see here, this is the true loyals, and they were predicted correctly, and these were the true churns, and they were predicted correctly. So what is the accuracy? The accuracy is really just this plus this over the entire data set, and then done 10 times an average to get the accuracy. Okay, great. So we talked a little bit about the accuracy of the model and the stability of the model, but let's just finish out this video with just a really brief discussion of recall and precision. All that recall is really just the percent of positive cases that we caught. In this case, add 509 plus 69, and then take 509 divided by that sum. You'll get 88%. Precision, on the other hand, are the percent of positive predictions that were correct. So all you do is add 509 plus 76, and then divide those by 509 to get 87%. And that's it. And that's how you effectively validate the model and see how good it is before you put it into production and deploy it. If you've watched this video and made it through the other past 4, congratulations. You now have a really good grasp on using RapidMiner Studio. So go forth and be productive. Thank you very much for watching.